The table shows information about the heights of 80 children. Find the class interval that contains the median. So the first thing we'll need to know is what the median is. So the median is the middle value when they are arranged in ascending order. So if we arrange these 80 children in ascending order of heights, the 40th and the 41st values would be the two middle values. So if we take a look at this frequency column, if there are 4 people between 130 and 140 centimetres, and there are 11 people between 140 and 150 centimetres, then this means there are 15 people between 130 and 150 centimetres. If there are 15 people between 130 and 150 centimetres, and 24 people between 150 and 160 centimetres, then this means there will be 39 people between 130 and 160 centimetres. And then if there are 22 people between 160 and 170 centimetres, and 39 between 130 and 160 centimetres, then this means there will be 61 between 130 and 170 centimetres. So now if we take a look at these values, this means when arranged in height order, the 39th child up until the 61st child will be between 160 and 170 centimetres. So this means this is where the 40th and 41st child will be. So this means the class interval that contains the median will be the class interval 160 is less than the height, which is less than or equal to 170 centimetres. And this question's worth 1 mark, and that's for the correct answer. Draw a frequency polygon for the information in the table. So what we can see from this graph is on the x-axis we have the height of the children, and on the y-axis we have the frequency. Now an important thing to remember for frequency polygons is that because the heights are in a class interval, we're going to want to take the midpoint of this interval. So for example, the midpoint of 130 to 140 centimetres will be 135 centimetres. So if we start off with the first row, heights between 130 and 140 centimetres, so the midpoint is going to be 135 centimetres and the frequency will be 4. So we want to plot the point 135, 4, and this will be here. Next, 140 to 150 centimetres, the midpoint will be 145 centimetres and the frequency is 11. So we'll plot the point 145, 11. Heights between 150 and 160 centimetres, the midpoint will be 155 centimetres and the frequency is 24. So we'll plot the point 155, 24. Heights between 160 and 170 centimetres, the midpoint will be 165 centimetres and the frequency is 22. So we'll plot the point 165, 22. And finally, heights between 170 and 180 centimetres, the midpoint will be 175 centimetres and the frequency is 19. So we'll plot the point 175, 19. And now the final thing we'll need to do to complete this frequency polygon is join up these points which we've plotted using a ruler. And this is what our completed frequency polygon should look like. And this question's worth 2 marks, and we'll get both of these marks for correctly completing the frequency polygon. In London, 1 litre of petrol costs 108.9 pence. In New York, 1 US gallon of petrol costs $2.83. 1 US gallon equals 3.785 litres. £1 equals $1.46. In which city is petrol of better value for money, London or New York? you must show you're working. So the information we've been told in the question is that in London, 1 litre of petrol costs 108.9 pence. In New York, 1 US gallon of petrol costs $2.83. One US gallon equals 3.785 litres. And then £1 equals $1.46. So if we take a look at this New York column, if 1 US gallon costs $2.83 and 1 US gallon is equal to 3.785 litres, then this means that 3.785 litres will cost $2.83. Now, as we can see, the prices in London are given in pence. However, the prices in New York are given in dollars. So we're going to want to convert this into pounds and then convert it into pence. So if £1 is equal to $1.46, and we want to work out what $2.83 is equal to, if we do 2.83 divided by 1.46, this gives us an answer of 1.938. So this tells us that in order to get from 1.46 to 2.83, we need to multiply by 1.938. So this means we can do the same calculation with the price, and 1 multiplied by 1.938 gives us 1.938. So this tells us that £1.938 is equal to $2.83. And this also means that 3.785 litres costs £1.938. And £1.938 is equal to 193.8 pence. So as we can see, the prices in London are given per 1 litre. However, we've worked out the price of 3.785 litres. So in order to work out the price per litre in New York, we're going to want to divide both the amount of litres and the price by 3.785. And 3.785 divided by 3.785 gives us 1 litre. And then 193.8 divided by 3.785 gives us 51.2. So what we can see, in London, 1 litre of petrol costs 108.9 pence, and in New York, 1 litre of petrol costs 51.2 pence. Therefore, the prices in New York are cheaper. So the final thing we can do is write a summary statement. So we can write something along the lines of, it will be cheaper in New York because 1 litre in London costs 108.9 pence, whereas 1 litre in New York costs 51.2 pence. Now this question's worth 3 marks. We'll get our first mark for working out the price of 3.785 litres in pounds. Our second mark for working out the price of 1 litre of petrol in New York, so that we can compare the prices of London and New York. And our third mark for stating that it will be cheaper in New York, along with the correct evidence. A gold bar has a mass of 12.5 kilograms. The density of the gold is 19.3 grams per centimetre cubed. Work out the volume of the gold bar. Give your answer correct to 3 significant figures. So we'll need to know the formula for the volume of a substance. And the formula for this is that volume is equal to mass divided by density. Now the next thing we'll need to do for this question is convert the mass of the gold bar into grams, because our density has been given in grams per centimetre cubed. And 1 kilogram is equal to 1,000 grams. And in order to get from 1 kilogram to 12.5 kilograms, we need to multiply by 12.5. So we can do the same to the right-hand side of this equation. And 1,000 times by 12.5 gives us 12,500 grams. So now we're going to want to substitute the mass of the gold bar and the density of the gold into this equation. So our mass in grams is 12,500 and our density is 19.3. And this gives us an answer of 647.67. And the units for our volume is centimetres cubed. Now the final thing we'll need to do for this question is give our answer correct to three significant figures. And 647.67 to three significant figures gives us 648 centimetres cubed. And this is our final answer. Now this question's worth 3 marks. We'll get our first 2 marks for a complete method, and we'll get our third mark for giving our answer correct to three significant figures. There are only blue pens, green pens and red pens in a box. The ratio of the number of blue pens to the number of green pens is 2 to 5. The ratio of the number of green pens to the number of red pens is 4 to 1. There are less than 100 pens in the box. Work out the greatest possible number of red pens in the box. So the first thing we can do is write out these two ratios in a more visual form. So the ratio of the number of blue pens to the number of green pens is 2 to 5. And then the ratio of the number of green pens to the number of red pens is 4 to 1. Now, as we can see, both of these ratios contain the colour green. So what we can do is we can combine these two ratios. But in order to do this, we'll need the number of green pens to be the same. So the lowest common multiple of 5 and 4 is 20. So we can multiply this ratio by 4 and multiply this ratio by 5. So 2 multiplied by 4 gives us 8, and 5 multiplied by 4 gives us 20. And then 4 multiplied by 5 gives us 20, and 1 multiplied by 5 gives us 5. And what this means is the ratio of blue to green to red pens is 8 to 20 to 5. So we've been told in the question there are less than 100 pens in the box. So we want to work out what the maximum number of pens we can put in the box with this ratio. So what we can do, we can add these three values together, and 8 plus 20 plus 5 gives us 33. So we want to work out how many lots of 33 we can fit into 100. So 3 multiplied by 33 gives us 99. And if we added another 33 pens, this would then be over 100. So what this tells us is that 3 lots of this ratio will fit into the box. So what we need to do is we need to multiply this ratio by 3. So 8 multiplied by 3 is 24, 20 multiplied by 3 is 60, and then 5 multiplied by 3 is 15. And the ratio we'll want to look at is the third ratio here. And the value we want to look at is this end value here, as this is the number of red pens. So this tells us that 15 red pens will be in the box. Now this question's worth 3 marks. We'll get our first mark for putting the two ratios in a form so that we are able to combine them. We'll get our second mark for combining the ratios, and our third mark for the correct answer. Find the value of the reciprocal of 1.6. Give your answer as a decimal. So a reciprocal of a number is the number which we need to multiply by a specified number to give an answer of 1. So if we let x be the reciprocal of 1.6, then this means that x multiplied by 1.6 gives us an answer of 1. And we'll need to rearrange this equation to make x the subject and therefore work out the reciprocal of 1.6. So what we can do is we can divide both sides by 1.6, and x multiplied by 1.6 divided by 1.6 gives us x, And then if we put 1 divided by 1.6 into our calculator, this gives us an answer of 0.625. And this is our final answer. And this question's worth 1 mark, and this is for the correct answer. Jess rounds a number x to 1 decimal place. The result is 9.8. Write down the error interval for x. So if Jess's result was 9.8, we need to think about the range of values, which we would round to 9.8. So if we start with below the number 9.8, we would round any number which is equal to 9.75 or above up to 9.8. So because this is including 9.75, we want to put a greater than or equal sign. And then the error interval is for the x. And then the values in which we would round down to 9.8 would be any number which is less than 9.85. And because it's less than, we'll just put a less than symbol. And this is because if it also included 9.85, then this would be rounded up to 9.9. So this is our final answer. And this question's worth 2 marks, and this is for the correct answer with the correct values and correct symbols. Here is a rectangle. The length of the rectangle is 7 centimetres longer than the width of the rectangle. 4 of these rectangles are used to make this 8-sided shape. The perimeter of the 8-sided shape is 70 centimetres. Work out the area of the 8-sided shape. So the first thing we can do is we can let x be equal to the width of the rectangle. And the width of this rectangle is this shorter length here. So we can label this up as x. And in the question we've been told that the length of the rectangle is 7 centimetres longer than the width of the rectangle. So if the width of the rectangle is x centimetres, then the length of the rectangle will be equal to x plus 7 centimetres. So now what we can do is start labelling up the lengths of these sides on this shape. So if we start with this side here, this is one of the lengths of the rectangle, so we can label this up as x plus 7. This shorter length here at the top is the width, so this is x centimetres. This length will be x plus 7 centimetres. This is another width, so this will be x centimetres. Now this side here is equal to 1 length of this rectangle minus 1 width of this rectangle. And if the length of the rectangle is x plus 7 centimetres and the width is x centimetres, then this side length will be equal to x plus 7 minus x centimetres, which is 7 centimetres. The next side is x plus 7 centimetres. This is a width, so will be x centimetres. This is a length, so will be x plus 7 centimetres. The next side is a width. And then finally we have another side which will be equal to 7 centimetres. Because again, this is a length, and then this shorter side here is a width. Now we've been told that the perimeter of this 8-sided shape is 70 centimetres. So what this means is all of these side lengths added together will be equal to 70 centimetres. So what we can do is form an expression from this. So if we start with this x plus 7 here, then this gives us that 70 is equal to x plus 7 plus x plus 7 plus x plus 7 plus x plus x plus 7 plus x plus 7 plus x plus 7 plus x. And now what we want to do is simplify down all the x terms and then simplify down all the numerical terms. So if we count the number of x's we have 1, 2, 3, 4, 5, 6, 7, 8 x's. So 70 will be equal to 8x And if we add up all the numerical terms, we have 6 7s. So the perimeter of this shape will be equal to 8x plus 42. So now what we're going to want to do is simplify down this equation to make x a subject. So the first thing we can do is minus 42 from both sides. And 70 minus 42 gives us 28. And 8x plus 42 minus 42 gives us 8x. And now the final thing we can do is divide both sides by 8. And this tells us that x is equal to 3.5. Now the final part of this question is to work out the area of the 8-sided shape. Now we've been told that 4 of these rectangles make up this 8-sided shape, so we can multiply the area of this rectangle by 4, and this will give us the area of this shape here. So the area of a rectangle is equal to the width multiplied by the length. So in terms of this question, our width was x centimetres and our length was x plus 7 centimetres. Now the value we worked out for x was 3.5, so we can substitute this into our formula. And this gives us that 3.5 multiplied by brackets 3.5 plus 7 is equal to the area of the rectangle. So if we remember our BODMAS rules, we'll always do the brackets before the multiplication. So we can start off with 3.5 plus 7, and this gives us 10.5. And finally 3.5 multiplied by 10.5 gives us 36.25. However, this is just the area for one of the rectangles. So in order to work out the area of the 8-sided shape, which is made up of 4 of these rectangles, we'll need to multiply this value by 4. And this gives us a final answer of 147 centimetres squared. Now this question's worth 5 marks. We'll get our first mark for letting the side lengths be equal to x and x plus 7. We'll get our second mark for having at least 6 of these side lengths correct. We'll get our third mark for forming an equation from the perimeter. Our fourth mark for working out that the width is equal to 3.5 centimetres. And our final mark for the correct area. Work out 13.8 times 10 to the power of 7 multiplied by 5.4 times 10 to the power of negative 12. Give your answer as an ordinary number. So 13.8 multiplied by 10 to the power of 7 multiplied by 5.4 times 10 to the negative 12 is the same as writing 13.8 multiplied by 5.4 multiplied by 10 to the power of 7 multiplied by 10 to the power of negative 12. And this can make it easier to work out. And we can either put this straight into a calculator, or we can work it out in 2 separate halves. So if we start off with 13.8 multiplied by 5.4, this gives us an answer of 74.52. And then we can use our rules of indices to work out 10 to the power of 7 multiplied by 10 to the negative 12. And when multiplying numbers with powers, we'll add the powers together. So 7 add negative 12 gives us negative 5. So this means that 10 to the power of 7 multiplied by 10 to the power of negative 12 is equal to 10 to the power of negative 5. So now the final thing we need to do is change our answer into an ordinary number. So as before, we can either put this into our calculator, or we can use this negative 5 to know that we need to move this decimal point 5 places to the left. So if we rewrite 74.52 with 3 zeros in front, and then we move the decimal point 5 places to the left, this then places the decimal point here. And this is 74.52 times 10 to the negative 5 as an ordinary number. And this is our final answer. Now this question's worth 2 marks. and we'll get both marks for having the correct answer. When a drawing pin is dropped, it can land point down or point up. Lucy, Mel and Tom each dropped the drawing pin a number of times. The table shows the number of times the drawing pin landed point down and the number of times the drawing pin landed point up for each person. Rachel is going to drop the drawing pin once. Whose results will give the best estimate for the probability that the drawing pin will land point up? Give a reason for your answer. So if we take a look at this table, the person whose results will give the best estimate for the probability the drawing pin will land point up will be the person who threw the drawing pin the most number of times. So what we can do for each Lucy, Mel and Tom is add together the number of times the pin landed point down and then the number of times the drawing pin landed point up. So if we start off with Lucy, the pin landed point down 31 times and the pin landed point up 14 times. So the number of throws that Lucy had will be 31 plus 14, which gives us 45. Next we can move on to Mel. The pin landed point down 53 times and the pin landed point up 27 times. So this means she had 80 throws in total. And finally, for Tom, the pin landed point down 16 times and point up 9 times. So Tom threw the pin 25 times. So therefore, Mel will give us the best estimate for the probability because Mel threw the pin the most number of times. So we can write this as our answer. So we can write that Mel will give the best estimate for the probability the pin will land point up because she threw the pin the most number of times. And this question's worth 1 mark, and this is for our answer. Stuart is going to drop the drawing pin twice. Use all the results in the table to work out an estimate for the probability that the drawing pin will land point up the first time and point down the second time. So the first thing we'll need to do for this question is work out the probability that the pin will land point up and then the probability that the pin will land point down. So if we start off with the probability that the pin will land point up, because we're using all of the results in the table, so our probability that the pin will land point up will be equal to the number of throws which landed point up divided by the total number of throws. So the number of throws which landed point up is in this row here. So it will be equal to 14 plus 27 plus 9. And then the total number of throws will be equal to 45 plus 80 plus 25. And if we simplify this down, this will give us an answer of 50 over 150. And we can use the same process for the probability that the pin will land point down. So the pin landed point down 31 plus 53 plus 16 times. And the total number of throws is still 150. And again, if we simplify this down, this gives us 100 over 150. So now the final thing we'll need to do is multiply these two values together. And this is because we want to find the probability that the drawing pin will land point up the first time and then point down on the second time. And if we put 50 over 150 multiplied by 100 over 150 into our calculator, it gives us a probability of 2 over 9. And this is our final answer. Now this question's worth 2 marks. We'll get our first mark for working out the probability the pin will land point up and also point down. And we'll get our second mark for the correct answer. Jack bought a new boat for £12,500. The value V of Jack's boat at the end of n years is given by the formula V equals 12,500 multiplied by 0.85 to the power of n. At the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? So if we want to work out after how many years the value of Jack's boat was first less than 50%, then we'll need to work out what 50% of the original price was. So we can do this by dividing 12,500 by 2. And this gives us an answer of £6,250. So what we want to work out is for what value of n this equation will be less than 6,250. So to do this we can use trial and error, and we can start substituting in values for n. So when n equals 1, v will be equal to 12,500 multiplied by 0.85 to the power of 1. And this tells us that v is equal to 10,625. Now 10,625 is not less than 6,250, so we can move on to when n equals 2. So when n equals 2, v will be equal to 12,500 multiplied by 0.85 squared. And this gives us a value of £9,031.25. Now this is also not less than 6,250, so we can move on to when n equals 3. So when n equals 3, v equals 12,500 multiplied by 0.85 to the power of 3. And this gives us a value of £7,676.56, which is also not less than 6,250, but we can see we're getting closer to the value now. So when n equals 4, v will be equal to 12,500 multiplied by 0.85 to the power of 4, and this gives us that v is equal to £6,525.08. However, this is still not below 6,250. So if we substitute in n equals 5, v will be equal to 12,500 multiplied by 0.85 to the power of 5. And this gives us that v is equal to £5,546.32. Now as we can see, the value is now less than £6,250. And if n is equal to the years, then this means that the year that the value of Jack's boat first went less than 50% would be at the end of year 5. So this is our final answer. Now this question's worth 2 marks. We'll get 1 mark for substituting any value of n into the formula given above, and our second mark for the correct answer. A savings account pays interest at a rate of R% per year. Jack invests £5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20. Work out the value of R. So the first thing we're going to want to do for this question is work out the amount of interest Jack earns before he pays tax. So Jack pays tax on his interest at a rate of 40%, and after interest he gets £79.20. So if Jack is paying his tax at a rate of 40%, then this means he'll be getting 60% of his total interest. So this means that £79.20 is equal to 60% of his total interest. So in order to work out his original interest, we'll need to work out what 100% of £79.20 is. So we can do this by working out 1% and then multiplying this by 100. So in order to get from 60 to 1, we divide by 60, and then in order to get from 1 to 100, we multiply by 100. So we can do the same calculation to the left-hand side of this equation. So we'll want to divide £79.20 by 60 and then multiply it by 100. And this gives us a value of £132. Now in Jack's account, he invested £5,500 and he earned £132 of interest from this £5,500. So we can form an equation from this information, and we can write that 5,500 multiplied by r equals £132. And now we're going to want to rearrange this equation to make r the subject. And we can do this by dividing both sides by 5,500. So 5,500 multiplied by r divided by 5,500 gives us r. And then 132 divided by 5,500 gives us 0.024. And now the final thing we need to remember to do is to convert this from a decimal to a percentage, because this value of r is the multiplier which we'd use for the percentage. So we can do 0.024 multiplied by 100 to work out the percentage. And this tells us that his saving account pays at an interest rate of 2.4%. And this is our final answer. Now this question's worth 3 marks. We'll get our first mark for working out the amount of interest Jack earned before tax. We'll get our second mark for starting a process to work out the value of r, and our third mark for the correct answer. There are only blue counters, yellow counters, green counters and red counters in a bag. A counter is taken at random from the bag. The table shows the probabilities of getting a blue counter or a yellow counter or a green counter. Work out the probability of getting a red counter. So one thing we need to know for this question is that in scenarios like this, when one counter is being taken at random from a particular place, or in this particular question from the bag, all of the probabilities will add up to 1. So this means that the probability of choosing a blue counter or a yellow counter or a green counter or a red counter will equal 1. So this means that 0.2 plus 0.35 plus 0.4 plus the probability that the counter will be red will be equal to 1. And if we simplify this down, this gives us that 0.95 plus the probability the counter is red equals 1. And if we minus 0.95 from both sides of this equation, this tells us that the probability the counter will be red is equal to 0.05. And this is our final answer. And this question's worth 1 mark, and this is for the correct answer. What is the least possible number of counters in the bag? You must give a reason for your answer. So the first thing we should note for this question is the number of counters must be a whole number. So each of these probabilities must represent a whole number. So what we can look for is a common factor for each of these 4 numbers. And the highest common factor for these numbers is 0.05. And because the probability of choosing out a red counter is 0.05, then this means that there is 1 red counter in the bag. And what we can do is divide 0.05 by each of these other 3 probabilities and then add up the total. So 0.2 divided by 0.05 is 4, 0.35 divided by 0.05 is 7, and then 0.4 divided by 0.05 is 8. And we worked out we had 1 red counter, and if we add these all together, this gives us a total of 20 counters. So this means that the least possible numbers of counters in the bag is 20, and the reason for this is because the number of counters for each colour must be a whole number. And this question's worth 2 marks. We'll get our first mark for stating the least possible number of counters in the bag, and our second mark for a valid reason. The cumulative frequency graph shows information about the weights of 60 potatoes. Use the graph to find an estimate for the median weight. So the median is the middle value when we arrange the weights of the 60 potatoes in size order. So this means that the median will be the 30th potato along. So we want to look at where the cumulative frequency is equal to 30. So an estimate for the weight when the cumulative frequency is 30 will be 57 grams. And this is our final answer. And this question's worth 1 mark, and this is for the correct answer. Jamil says 80 minus 40 is equal to 40, so the range of weights is 40 grams. Is Jamil correct? You must give a reason for your answer. So when drawing cumulative frequency graphs, we use grouped data. So what this means is we'll be given a frequency for a particular class interval. And if we look at this graph, an example of this could be that there are 10 potatoes with weights between 30 and 50 grams. So therefore, although Jamil is correct in saying that the graph starts and ends at 40 and 80 grams, this does not necessarily mean the range is 40 grams, because we don't know whether the highest value is 80 grams or the lowest value is 40 grams. So we could write that no, Jamil may not be correct, because we don't know whether the highest weight is 80 grams or less than 80 grams. And we can use the same argument for the lowest weight, as we don't know whether 40 grams is the lowest weight, or whether the lowest weight is above 40 grams. And this question's worth 1 mark, and that's for a decision with the supporting evidence. Show that less than 25% of the potatoes have a weight greater than 65 grams. So for this question, we want to read off the graph at 65 grams, and if less than 25% of the potatoes have a weight greater than 65 grams, then this means that the cumulative frequency at 65 grams must be above 45, which is here. So if we draw a line going up from 65 grams, the cumulative frequency at 65 grams is around 48. So the final thing we'll need to do for this question, in order to get the mark, is write a statement on why there are less than 25% of potatoes with a weight greater than 65 grams. So we can write that 25% of the potatoes would be 15 potatoes. However, only 12 have a weight greater than 65 grams. Now this question's worth 2 marks. We'll get our first mark for drawing a line on our graph indicating that we've worked out the cumulative frequency from the weight at 65 grams, and our second mark for a summary statement. Alan has 2 spinners, spinner A and spinner B. Each spinner can land on only red or white. The probability that spinner A will land on red is 0.25. The probability that spinner B will land on red is 0.6. Alan spins spinner A once and he spins spinner B once. He does this a number of times. The number of times both spinners land on red is 24. Work out an estimate for the number of times both spinners landed on white. So the first thing we can do for this question is work out the value for the probability that both spinners will land on red, and then the probability that both spinners will land on white. So if we look at the tree diagram, the probability spinner A is red is 0.25, and then the probability that spinner B is red is 0.6. And because we want the probability that spinner A and spinner B will be red, then this means the probability will be equal to 0.25 multiplied by 0.6, which gives us a probability of 0.15. And we can use the same process for the probability that both spinners will be white. So the probability that spinner A is white is 0.75, and then the probability that spinner B is white is 0.4. So the probability that both spinners are white is 0.75 multiplied by 0.4, which gives us an answer of 0.3. So the number of times that both spinners land on red is 24, and we can treat this value as though it's proportional to the probability that both spinners are red. And the probability that both spinners are red is 0.15. So because we want to work out an estimate for the number of times both spinners land on white, we've worked out that the probability that both spinners will land on white is 0.3. And in order to get from 0.15 to 0.3, we multiply by 2. So because we've doubled the chance of this event happening, then we can also double the number of times the event happened. So we can multiply 24 by 2, and this gives us an answer of 48. And this is our final answer. Now this question's worth 3 marks. We'll get our first mark for working out the probability that both spinners will be red. We'll get our second mark for working out the probability that both spinners will be white. And our third mark for the correct answer. Write x squared plus 6x minus 7 in the form x plus a squared plus b, where a and b are integers. So this is something which is called completing the square, and the general formula for an equation in this form is x plus b over 2 squared minus b over 2 squared plus c. Now this may look complicated at first, but this is a little bit easier to see when we do the question. So we've been told to write x squared plus 6x minus 7 into this form. So the first thing we're going to do is we're going to add a brackets into this. And then we're going to change this x squared term to an x term. And then we have this b over 2 up here. So what we're going to do is we're going to half the coefficient of the x term. So this gives us plus 3. And then we'll close the brackets. And what we're going to do is we're going to square all of this. Now if we were to expand out this expression here, this would give us x squared plus 6x plus 9. So the reason that we minus this b over 2 squared is so that it's equal to x squared plus 6x. So we're going to minus 9. And then the final thing to remember is this negative 7 at the end. And now the final thing we need to do for this question is simplify this down. And this gives us an answer of x plus 3 squared minus 16. And this question's worth 2 marks. We'll get our first mark for having this x plus 3 squared part of the equation correct, and our second mark for the full correct answer. Cone A and cone B are mathematically similar. The ratio of the volume of cone A to the volume of cone B is 27 to 8. The surface area of cone A is 297 centimetres squared. Show that the surface area of cone B is 132 centimetres squared. So the first thing we can do is write out the ratio of the volume of cone A to the volume of cone B in a more visual form. So the ratio of the volume of cone A to cone B is 27 to 8. So in order to work out the ratio of the side lengths, we'll need to cube root these values. So the cube root of 27 is 3, and the cube root of 8 is 2. Now in order to do this question, we'll need to know the ratio of the surface areas. And in order to do this, we'll need to square all the terms. So 3 squared is 9, and then 2 squared is 4. So what this means is the surface area of cone A to the surface area of cone B is in a ratio of 9:4. So because the ratios are 9:4 and the surface area of cone A is 297, then in order to work out the surface area of cone B, we'll need to work out how many times we need to multiply 9 to get 297, and then multiply this value by the 4. And because it is a show that question, we know we've done our workings correct if we get an answer of 132 centimetres. So in order to get from 9 to 297, we need to multiply by 33. So we can do the same calculation to the right-hand side of this ratio. And 4 multiplied by 33 gives us 132. So now the final thing we can do is write a summary statement. So we can write that therefore, because the ratio of surface areas is 9:4, the surface area of cone B is 132 centimetres squared. Now this question's worth 3 marks. We'll get our first mark for working out the ratio of the side lengths. We'll get our second mark for working out the ratio of the surface areas. And we'll get our final mark for showing that the surface area of cone B is 132 centimetres squared, using the correct calculations. Show that the equation x cubed plus 7x minus 5 equals 0 has a solution between x equals 0 and x equals 1. So the first thing we're going to want to do is substitute these two values of x into this equation here. So if we start off with when x equals 0, x cubed plus 7x minus 5 will be equal to 0 cubed plus 7 multiplied by 0 minus 5, which gives us an answer of negative 5. And then when x equals 1, x cubed plus 7x minus 5 is equal to 1 cubed plus 7 multiplied by 1 minus 5, which gives us 3. Now a solution to this equation is a value which we can substitute in for x to make this equation equal to 0. So if we draw a zoomed in version of this graph, where x equals 1 is here, the graph would look something like this going through 1. And the solution for this equation would be here. And we can see this value is between 0 and 1. So therefore, because one of these values is negative and one of these values is positive, then this solution has an equation between x equals 0 and x equals 1. So the final thing we can do is write a summary statement. So we can write something along the lines of, therefore, the equation x cubed plus 7x minus 5 has a solution between x equals 0 and x equals 1 because one of the values is negative and one of the values is positive. And this question's worth 2 marks. We'll get 1 mark for substituting the values of x into the equation, and the second mark for showing that the equation has a solution between x equals 0 and x equals 1 with the correct evidence. Show that the equation x cubed plus 7x minus 5 equals 0 can be arranged to give x equals 5 over x squared plus 7. So the first thing we can do for this question is we can factorise out an x term from these first 2 terms here. And this will give us x multiplied by x squared plus 7 minus 5. So now the next thing we can do is add 5 to both sides of this equation. And this gives us x multiplied by x squared plus 7 equals 5. So now the final thing we need to do is divide both sides of the equation by x squared plus 7. And this gives us that x is equal to 5 over x squared plus 7. Now this question's worth 2 marks. We'll get our first mark for factorising out the original equation, and our second mark for the complete correct solution. Starting with x0 equals 1, use the iteration formula xn plus 1 equals 5 divided by xn squared plus 7, 3 times to find an estimate for the solution of x cubed plus 7x minus 5 equals 0. So essentially for this question, we're going to want to work out what the value of x3 will be. So we can use this equation by starting off with x0 and repeating this 3 times until we get the answer for x3. So x1 is equal to 5 divided by x0 squared plus 7. So we can substitute in the value x0 equals 1 into this equation. And this tells us that x1 is equal to 5 divided by 1 squared plus 7. And this gives us an answer of 0.625. So we can use the same process to find the value of x2. So x2 will be equal to 5 divided by x1 squared plus 7. And we can either use our answer button on our calculator to substitute in the value for x1, or we can type in 0.625. Either way will work. So this tells us that x2 is equal to 5 divided by 0.625 squared plus 7, which gives us an answer of 0.67653277. And again we can use the same process to find the value of x3 and therefore find our answer. So x3 will be equal to 5 divided by x2 squared plus 7. And again we can replace this number with the answer key on our calculator, or we can write out the number in full into our calculator. However, it's important that we don't round this number too early on in the question, as this will reduce the accuracy of our answer. So if we put this into our calculator, this gives us a value of x3 as 0.670448. And we don't need to round this value any further. Now this question's worth 3 marks. We'll get our first mark for substituting 1 into the formula to give us the value of x1. We'll get our second mark for substituting in the value of x1 and the value of x2 into the formula to give us the values of x2 and x3. And we'll get our final mark for the correct answer to at least 4 decimal places. By substituting your answer to part C into x cubed plus 7x minus 5, comment on the accuracy of your estimate for the solution to x cubed plus 7x minus 5 equals 0. So what we want to do is we want to substitute our answer from part C into this equation. And if we get a value that's near to 0, we can say that our estimate is fairly accurate. So if we substitute our answer from part C into x cubed plus 7x minus 5, this will give us 0.670448 cubed plus 7 multiplied by 0.670448 minus 5. And this gives us an answer of negative 0.0054948. So as we can see, negative 0.0054948 is fairly close to 0. So we can say that our estimate is pretty accurate. So now the final thing we need to do is write down our reasoning. So we can write something along the lines of the estimate is accurate because the substitution gives us a value which is close to 0. Now this question's worth 2 marks. We'll get our first mark for substituting in our answer from part C into the given equation, and we'll get our second mark for explaining why the estimate is accurate. The petrol consumption of a car in litres per 100 kilometres is given by the formula petrol consumption is equal to 100 multiplied by the number of litres of petrol used, divided by the number of kilometres travelled. Nathan's car travelled 148 kilometres, correct 3 significant figures. The car used 11.8 litres of petrol, correct to 3 significant figures. Nathan says, my car used less than 8 litres of petrol per 100 kilometres. Could Nathan be wrong? You must show how you get your answer. So Nathan's statement is that my car used less than 8 litres of petrol per 100 kilometres. Now petrol consumption is given in litres per 100 kilometres, so we want to work out the largest possible value for the petrol consumption with the figures that we've been given in the question. So in order to produce the largest number possible for the petrol consumption, we'll want to use the upper bound for the number of litres of petrol used, and we'll want to use the lower bound for the number of kilometres travelled. So the first thing we can do is work out what the upper bound for the number of litres of petrol will be. So the car used 11.8 litres of petrol, so we want to work out the largest possible value of litres, which would still round down to 11.8. And the largest value for this would be 11.849 reoccurring. However, we can round this up to 11.85. So this means that our upper bound is equal to 11.85. Next, we can move on to the number of kilometres travelled. So we want to work out what the lower bound for this is. So Nathan travelled 148 kilometres. So similar to before, we want to find a value which will round to 148. However, this time we're working out the lowest value. And the lowest value, which would still round up to 148 kilometres, would be 147.5 kilometres. So this is our lower bound. So the next thing we can do is substitute in these two values to work out what the maximum possible petrol consumption could be. So our petrol consumption is equal to 100 multiplied by the number of litres of petrol used. And we worked out that the upper bound for the litres of petrol is 11.85, and then divided by the number of kilometres travelled. And we worked out our lower bound was 147.5 kilometres. And these are the two values which we'll use in our equation. And this gives us a petrol consumption of 8.0339. So as we can see, this value is greater than the value that Nathan stated. So therefore, Nathan could be wrong. So now the final thing we'll need to do for this question is write a summary statement. So we can write something along the lines of, yes, Nathan could be wrong because the maximum petrol consumption is 8.0339. And this question's worth 3 marks. We'll get our first mark for working out at least one of either the upper bound or the lower bound. We'll get our second mark for substituting both the upper bound and the lower bound into the petrol consumption formula. And we'll get our final mark for stating that yes, Nathan could be wrong with the supporting evidence. ABC and ADC are triangles. The area of triangle ADC is 56 metres squared. Work out the length of AB. Give your answer correct to 1 decimal place. So an important thing to remember for this question is to write out all the information which we work out onto the diagram. So the first thing we can do is use the formula for the area of a triangle to work out what this length CD is equal to. So the area of a triangle is equal to a half AB sin C. So if we let length AD be equal to A, length CD to be equal to B, which would therefore make this 105 degrees angle C. And we've been told in the question that the area of triangle ADC is 56 metres squared. So this means that 56 is equal to a half multiplied by 11 multiplied by CD multiplied by sin 105. And if we simplify this down, this gives us that 56 is equal to 5.313 multiplied by CD. And now what we can do is divide both sides by 5.313, which tells us that side length CD is equal to 10.54 metres. So we can write this into our diagram. So the next thing we can do is use this information to work out what the side length of AC is equal to. And we can do this by using the cosine rule. So the cosine rule is that a squared is equal to b squared plus c squared minus 2bc cos. So if we want to work out the length of AC, then we can let AC be equal to A. And if we put the right hand side of this equation into our calculator, this tells us that side length AC squared is equal to 292.107. And if we square root both sides of this equation, this tells us that side length AC is equal to 17.1 metres. And again we can write this into our diagram. So now we have enough information to work out the length of side AB, and we can work it out by using the sine rule. And the sine rule is that A divided by sin A is equal to B divided by sin B. So we can label up these side lengths. So if we label up the angles and side lengths in triangle ABC, we can let side length AB be equal to A, side length AC be equal to B, which would therefore make angle BCA angle A, and angle ABC angle B. So we can substitute these values into the sine rule. And if we substitute these values in, this gives us that AB divided by sin 48 is equal to 17.1 divided by sin 118. And if we multiply both sides of this equation by sin 48, this tells us that side length AB is equal to sin 48 multiplied by 17.1 divided by sin 118. And if we put this into our calculator, this gives us that side length AB is equal to 14.4 metres. And this is our final answer. Now this question's worth 5 marks. We'll get our first mark for substituting in the values into the formula for the area of a triangle. We'll get our second mark for rearranging this equation to work out the side length of CD. We'll get our third mark for using the cosine rule to work out the side length of AC. We'll get our fourth mark for using the sine rule to work out the side length of AB. And we'll get our fifth mark for the correct answer to 1 decimal place. Here is a speed time graph for a train. Work out an estimate for the distance the train travelled in the first 20 seconds. Use 4 strips of equal width. So because this is a speed time graph, the distance travelled is equal to the area under the graph. So in order to work out an estimate for the distance the train travelled in the first 20 seconds, we'll want to estimate the area under the graph between the times of 0 seconds and 20 seconds. However, we've been told to use 4 strips of equal width. So what we can do is split this area into 4 vertical widths. So what we need to do is work out what these 4 areas are equal to and then add them all together. So what we can see is the first strip is a triangle and then the other strips are trapeziums. So we'll need to know the formula for the area of a triangle and then the area of a trapezium. So the area for a triangle is a half multiplied by base multiplied by height. And then the area for a trapezium is half the sum of the parallel lines multiplied by the height between them. So if we start off with the time between 0 and 5 seconds, the area will be equal to half multiplied by 5 multiplied by 2, which gives us an answer of 5. So for the time between 5 and 10 seconds, our area will be equal to a half multiplied by 2 plus 5, which is the sum of the parallel lines, multiplied by the height between them, which is 5. And this gives us an answer of 17.5. Between 10 and 15 seconds, our area is equal to a half multiplied by 5 plus 10, which is the sum of our parallel lines, multiplied by 5, which gives us an answer of 37.5. And then finally between 15 and 20 seconds, the sum of our parallel lines will be 10 plus 18, and then the height between them is 5. So between the time of 15 seconds and 20 seconds, the area under the graph is equal to a half multiplied by 10 plus 18 multiplied by 5, which gives us an answer of 70. So now the final thing we need to do is add together these four values to give us an estimate for the distance the train has travelled in the first 20 seconds. So 5 plus 17.5 plus 37.5 plus 70 gives us an answer of 130. Now this question's worth 3 marks. We'll get our first 2 marks for using a suitable method to work out the area of each of the 4 strips, and we'll get our 3rd mark for the correct answer. Is your answer to A an underestimate or an overestimate of the actual distance the train travelled? Give a reason for your answer. So if we take a look back at the graph, the shape of the graph is curved. However, when we worked out the area under the graph, we've also included this space between the trapezium and the curve. So therefore, our answer to part A is an overestimate. So we can write in our answer that our answer to part A was an overestimate because we have also included the area between the trapezium and triangle and the curve. And this question's worth 1 mark, and we'll get that 1 mark for stating that the answer is an overestimate with a suitable reason. Prove algebraically that the straight line with the equation x minus 2y equals 10 is a tangent to the circle with equation x squared plus y squared equals 20. So in order to prove that a straight line is a tangent to a circle, essentially what we need to do is to prove that it only intersects the circle once. Now this is what a tangent looks like. So the reason we need to prove that there's only one point of intersection is to show that it only touches the circle once. However, this line at the bottom is not a tangent because it has 2 points of intersection with the circle. So what we'll need to do is substitute this straight line equation into the equation for the circle. However, the first thing we'll need to do is rearrange this equation. So if we add 2y to both sides of this equation, this gives us that x is equal to 2y plus 10. And now we can substitute in 2y plus 10 in place of the x in the circle equation. So this will give us that 2y plus 10 squared plus y squared is equal to 20. And now what we need to do is expand out this equation and then make it equal to 0. So if we expand out the 2y plus 10 squared in this equation, this gives us 4y squared plus 20y plus 20y plus 100 plus y squared is equal to 20. And if we collect all of the like terms, this gives us 5y squared plus 40y plus 100 equals 20. So as we can see, we've formed a quadratic equation here. However, in order to solve this, we'll need to make it equal to 0. So we can minus 20 from both sides of the equation. And this gives us that 5y squared plus 40y plus 80 is equal to 0. Now there's a few different ways that we can solve this equation, such as putting it into the quadratic formula or factorising the equation. However, in order to make it easier to factorise, we can divide both sides by 5. So 5y squared divided by 5 gives us y squared. 40y divided by 5 gives us 8y. And then 80 divided by 5 gives us 16. And then 0 divided by 5 is still 0. So now in order to factorise this equation, we want to find two numbers which will add together to give us 8 and multiply together to give us 16. So 4 plus 4 gives us 8 and then 4 multiplied by 4 gives us 16. So therefore we can factorise this quadratic into y plus 4 multiplied by y plus 4, which we can again simplify down to y plus 4 squared. So in order to make this equation true, so to make this equation equal to 0, y would have to equal negative 4. And there are no other values which we could substitute into this equation for y, which would make this equation true. So therefore we've shown that there's only one intersection of the straight line and the circle. So now the final thing we need to do for this question is write a summary statement. So we can write something along the lines of, therefore the straight line is a tangent to the circle because there is only one point of intersection. Now this question's worth 5 marks. We'll get our first mark for substituting the equation of the straight line into the equation of the circle. We'll get our second mark for expanding out the brackets. We'll get our third mark for making this equation equal to 0. We'll get our fourth mark for solving the quadratic. And we'll get our fifth mark for stating that the reason that the straight line is a tangent to the circle is because there is only one point of intersection, along with the supporting evidence. A, B and C are points on the circumference of a circle, centre O. AOB is the diameter of the circle. Prove that angle ACB is 90 degrees. You must not use any circle theorems in your proof. So the first thing we can do is split this triangle into two. And then we can label up these angles X and Y. Now because AOB is the diameter of the circle, then this means that line AOB must be a straight line. And because angles on a straight line add up to 180 degrees, this means that X plus Y is equal to 180 degrees. Now because AOB is the diameter of the circle, then this means that AO, OC and OB are all half the length of the diameter, making them a radius, and therefore making them equal in length. So what this means is that both of these triangles are isosceles triangles. Now if we want to prove that angle ACB, which is this one here, is 90 degrees, we'll need to work out what angle CAB is and work out what angle ABC is. And we can do this in terms of x and y. So if we start off with angle CAO, because this is an isosceles triangle, angle CAO is equal in size to angle ACO. So this means that 2 multiplied by angle CAO plus x is equal to 180 degrees. And if we minus x from both sides, this gives us that 2 multiplied by angle CAO is equal to 180 minus x degrees. And if we divide both sides by 2, this gives us that angle CAO is equal to 180 minus x divided by 2 degrees. So we can write this into our diagram. And if we use the same process for angle ABC, in which angle OCB and angle OBC are equal, then this makes angle ABC equal to 180 minus y divided by 2 degrees. So now what we have is 2 out of 3 of the angles on this triangle. And because angles in a triangle add up to 180 degrees, when we add together angle CAB, angle ABC and angle ACB, this will give us 180 degrees. So the first thing we can do is write this into a different form so that it is easier to rearrange. So 180 minus x divided by 2 can be written as 90 minus x over 2. And then 180 minus y divided by 2 can be rewritten as 90 minus y over 2. And if we collect all the like terms, this gives us that 180 minus x over 2 minus y over 2 plus angle ACB is equal to 180 degrees. Now the next thing we can do is factor out negative a half from this negative x over 2 minus y over 2. And what this gives us is 180 minus a half multiplied by x plus y plus angle ACB is equal to 180 degrees. Now if we look back at the start of the question, we showed that x plus y was equal to 180 degrees. So we can substitute this into the equation which we've formed. So when we substitute this in, this gives us 180 minus a half multiplied by 180 plus the angle ACB is equal to 180. So next we can expand out these brackets, and this gives us 180 minus 90 plus the angle ACB is equal to 180. And then if we put all of the numerical terms onto one side of this equation, this tells us that angle ACB is equal to 90 degrees. And that is our final proof. Now this question's worth 4 marks. We'll get 1 mark for splitting this triangle into 2 separate triangles. We'll get our second mark for showing the sum of the angles at point O in terms of x and y. We'll get our third mark for a complete method showing that angle ACB is equal to 90 degrees. And we'll get our fourth mark for all the correct reasoning. OAN, OMB and APB are straight lines. AN is equal to 2OA, M is the midpoint of OB, OA equals A, OB equals B, AP equals KAB, where K is a scalar quantity. Given that MPN is a straight line, find the value of K. So the first thing we can do is annotate this diagram with the information we've been given in the question. So we've been told that AN is equal to 2OA, and we've also been told that OA is equal to A. So therefore, if OA is equal to A, and AN is equal to 2OA, then this means A to N is equal to 2A, which means the full line OAN is equal to 3A. Next, we've been told that M is the midpoint of OB, and that OB is equal to B. So therefore, if the full length OB is equal to B, and M is the midpoint, then this means O to M will be equal to a half B, and MB will also be equal to a half B. We can also draw in the line MPN. So the first vector we can work out is the line A to B. So the line AB will be equal to negative OA plus OB. And OA is equal to A, so therefore negative OA is equal to negative A. And then OB is equal to B. So the next thing we can do is work out what the line MN will be equal to. So MN will be equal to negative MO plus O to N plus ON. And O to M is a half B, so therefore negative O to M will be negative a half B. And then O to N is equal to 3A. So we've been told that line MPN is a straight line. And one thing we need to know, if two vectors are on the same line, one will be a multiple of the other. So what we're going to want to do for this question is add in another variable. And we can let this variable be equal to x. So because MN and MP are both on the same line, MP will be equal to x multiplied by MN. And we worked out that MN was equal to negative a half B plus 3A. So therefore MP is equal to x multiplied by negative a half B plus 3A. So the next thing we can do is work out what MP would be equal to in terms of K. So we've been told that AP is equal to KAB. So therefore the route we could take could be M to O, O to A, and then A to P. So therefore, because O to M is equal to a half B, negative O to M will be negative a half B. M to A is equal to A, and then A to P is equal to K multiplied by AB. However, the first thing we did in this question was work out what AB was equal to, which is negative A plus B. So we can substitute this vector into this expression. So now what we've got is we have two different expressions for MP. So what we can do is put these two expressions equal to each other. So the first thing we can do is expand out these brackets. So x multiplied by negative a half b is negative a half xb. X multiplied by 3a is 3xa. And then k multiplied by negative a gives us negative ak. And then k multiplied by b gives us KB. So now what we're going to want to do is factorise out A and B on the right hand side of this equation. So first we can factorise out B. So we can factorise B from negative a half B and KB. And this will give us K minus a half multiplied by B. And next we can factorise out the A from A minus AK. And this gives us 1 minus K multiplied by A. So now what we can do is something called comparing the coefficients. So this involves comparing the coefficients for both the A and the B term. And then we'll be able to form a simultaneous equation to work out the value of K. So if we start off with B, negative a half xb is equal to K minus a half B. So therefore negative a half x is equal to K minus a half. And then we can use the same process for the A term. So 3xa is equal to 1 minus Ka. So therefore 3x is equal to 1 minus K. So now in order to work out the value of K, we're going to want one of these coefficients to be the same for the x term. So now what we can do is multiply both sides of this equation by negative 6. And this gives us that 3x is equal to negative 6k plus 3. So now what we have is two equations for 3x. So we can put these two equations equal to each other. And this gives us 1 minus k is equal to negative 6k plus 3. So now the final thing we need to do is rearrange this equation to make k the subject in order to get our final answer. And if we rearrange this equation, this gives us that k is equal to 2 over 5. And this is our final answer. Now this question's worth 5 marks. We'll get our first mark for finding AB. We'll get our second mark for finding MN. We'll get our third mark for finding MP. We'll get our fourth mark for putting MN as a multiple of MP. And we'll get our fifth mark for the correct answer.